So for this problem, we are told to use a matrix to solve. And we have a word problem. So first we're going to read through that word problem, and then we're going to try to model that word problem with some equations. And then we're going to let the matrix take care of the algebra for those equations. So reading, it says a woman's purse contains 10 spilled pills. Some are 5 milligram and some are 3 milligram. She spilled a total of 44 milligrams. How many of each pill spilled? So when we are dealing with a word problem, one strategy we said is to write an items equation and then a value equation. And it feels like this word problem is going to fit into that strategy. So as far as items, there are 10. And as far as the value, some have a value of 5 milligrams, so that's a value. Some have a value of 3 milligrams, and this 44 is going to be a total value for all of them together. So it looks like my two things, my two items are these different kinds or different strengths of the pills. So the 5 milligram pill, I'm going to let that be my X, and the 3 milligram pill, I'm going to let that be my Y. So sum of the first kind of pills, X, plus sum of the second kind of pills, Y, is going to be 10 pills in total. And then those first pills, they each had 5 milligrams, so 5X. The second kind of pills had 3 milligrams, so 3Y, for a total of 44 milligrams. So those two equations capture all the relationships. And when I look at how I wrote them in an orderly fashion. So X first, Y second, constant at the end. And so I can go directly into a matrix, because a matrix is always just an organized arrangement, not the variables, but all of the numbers. So I have an X column, a Y column, and a constant column. And I get to put in two equations, so equation 1 and equation 2. So from the first equation, my coefficients are 1, 1, and 10. My second equation, they are 5, 3, and 44. So once I have my matrix set up, I'm going to go to my calculator for it to do all of the work on this matrix rather than doing that work by hand. So in my calculator, I'm going to use the second button and the X to the -1 button, and I'm going to arrow over here to edit the matrix. Now it does have the matrix in from my last problem, so I need to change all of this. So this matrix is 2 equations, 3 entries per equation, so that reduces the size. My first equation has coefficients of 1, 1, and 10. My second equation had coefficients of 5, 3, and 44. All right, so my matrix is in, and I have to quit. So second and the mode button gets me out of the matrix and back to my regular calculator screen. So now I have to go and tell it what math to do. So I go second and X to the -1 to get to matrix, arrow over to math, and then I typically arrow up, and we want option B, where it's going to go to the reduced row echelon form. So the full reduction here with the double R's to get that fully reduced. And then I have to tell it which matrix to work on. So second matrix button and enter so that it works on matrix A. Enter one more time and it gives me this answer matrix. So 107013. So going back to my PowerPoint, I do the reduced row echelon form, and it gave me this answer matrix 107013. So my last step then is just to interpret this matrix, which is the answer to my problem. So setup stays the same. So this first is the X column, Y column, and then constant column. I have two separate equations, equation 1 in the first row, equation 2 in the second row. So first thing I'm going to do is I'm just going to pull this first equation out, and these numbers that are in the matrix are literally the coefficients. So this is telling me 1x plus 0y is equal to the constant 7. Now, in algebra, we don't typically write it exactly like this. So when there's a 0 as the coefficient, we don't write that term at all. So I would not write 0y. And when there's a 1 as the coefficient, we don't write the 1. So this equation simplifies to just being x is equal to 7, because the 1x is just x, 0y does not need to be written, and so x is 7. Using all that same concepts for the second equation, the 1 is in the y column, and so the answer that I'm getting from the second equation is telling me that 1y is equal to 3. And so now I have my two answers, and I can just very quickly do a little double check on those. So if I put them into my first equation, x plus y is supposed to equal 10, and I can see that 7 plus 3 does indeed equal 10. So that's super easy to check. I actually can check the second one as well. So we said that x is 7, so this would be 5 times 7 plus 3 times 3, and that's supposed to equal 44. So does it? So we would get 35 plus 9, and that indeed does equal 44. So we can see that it checks there as well. And so matrix is a technology-dependent strategy that would solve a system of equations. Rather than doing the elimination or substitution method by hand, we have a way that technology can help us solve the system.